Now, this lesson will be a follow-up from the previous videos where we looked at solving quadratics and different ways to solve them. Today, we will be looking at completing the square. So we'll do a quick overview of solving quadratics and the different ways of how we can do this. Then we will look at a few examples of how to complete the square and some practice questions. So just a quick overview. When we are asked to solve for x, that means to find the values for x. And there are a few different ways that this can be done. One of the examples is graphically. So, for example, if we had a graph, a quadratic graph here, we would be able to solve for x by finding the two solutions for x where it crosses the x-axis. So for example, if this was 2 and this was 4, they would be our solutions for x. Adding to this, another way that we can solve for x would be by factorizing an equation. Another similar way would be the quadratic formula, where we take an equation, we plug in the values for a, b, and c, and that would give us the values for x. Simultaneous equation is similar to these above here. Now, the last one on this list is something called completing the square. And again, this is something that can be used on equations, and it's just another way of just solving for x. And with completing the square, we usually only use it if specifically asked. It's not usually our go-to, but it's still something that we need to know and understand why it is used. Now, completing the square is used for two things: solving for x and finding the turning point of a graph, which is the lowest point on a graph here. So if you look at this, for example, this would be the turning point, and we can find out the coordinates of this point using completing the square. Now let's look at an example here, and we can work out the solutions for x and the turning point. Okay, so this example is used where a equals 1. And what do we mean by that? First, we need to rearrange the equation, so it is in this formula of ax squared plus bx plus c. So we want a to equal 1, so there's no number in front of x, like we have here. Okay? No number in front of here just means 1. So once that's done, we open a bracket and we write in x plus or minus, depending on what the original equation has. This has a plus, so we're going to keep it like that. Half of b, and b is the number in front of x here. We half that, we get 2. The next step after that, we minus outside the bracket this half b squared. So 2 squared is 4. And lastly, we plus or minus, again, depending on what the original equation shows, here it's minus, this c value here. So we're going to write minus 3. Now let's simplify this. So this bracket stays the same, and we just add or minus these numbers outside the bracket. So that gives us minus 7. So if we were to solve this equation using completing the square, we would first have our answer as we worked out earlier, and we would make it equal 0. Now we just rearrange and solve for x as usual. So step by step, let's go through this. Take the 7 over. We have plus or minus the square root of 7. And now x is or minus the square root of 7. And there we have our two values for x. Now, when finding the turning point, it's a little bit easier. We take our original working out, and this turning point is just going to be one set of coordinates, one x value, one y value. Now the x value, we just need to take this number outside of the bracket, as we've done previously with things like factorization. So this will be -2, and the y value will stay the same as it's shown outside the bracket. Now, to show you what this would look like on a graph, for example, let's have just a quick sketch here. Now let's say this is the graph y equals x squared plus 4x minus 3. Our solutions for x would be here. So this would be -2 minus √7, and this would be -2 plus √7. Now this is just an estimate drawing of a graph. It might be off a little bit, but this is the theory behind it. And the turning point, which is the lowest point of the graph, would have the coordinates -2, -7. Okay, and this is how we use completing the square. Moving on now, we have another example, and this is where a does not equal 1. So we have an equation like this, where it's 2x squared. Okay, so the first step, as usual, we check that the formula is in this format here, which we can see that it is. Next, before we complete the square, we need to take out the value of a as a common factor and kind of factorize it in a sense, so that we can work with this equation, then multiply it by that factor. So we can see here the number in front of x is 2, so let's take that out. That will give us x squared plus 2x minus 4. Now, as you can see, we can now complete the square with this equation inside the bracket and then multiply our answer by 2 at the end. So let's do that now. Always remember to write out our common factor on the outside bracket so we don't forget to multiply at the end. So open square bracket, x plus half b minus x squared minus c. That gives us 2 multiplied by x plus 1 squared minus 5. Now we're going to multiply this 2 with all the terms in this equation. So the way we would write it out would be 2 brackets x plus 1 squared, so we're just going to leave it in that format, minus 2 times 5, which is 10. And just a quick pointer here that we didn't do in the previous example. If you want to check that you've completed the square correctly, all you have to do is just multiply out these brackets and simplify, and you should get your original equation here. So let's just do that now before we solve for x and find the turning point of this equation. So 2 multiplied by x plus 1, x plus 1. I'm going to multiply out these brackets. That will give us 2x squared plus 4x plus 2. Then we minus the 10, giving us a final answer of 2x squared plus 4x minus 8. And we can see it matches our original equation, so we know this is right. So now we're going to solve for x and find the turning point of this graph. Let's get rid of all of this here. So if we're solving for x, we need this equation to equal 0. And now we just rearrange and solve as normal. It's plus or minus root 5, giving us two solutions for x, which is minus 1 plus or minus root 5. Okay, now to find the turning point. Now this will just be one set of coordinates, and we take this value inside the bracket and we take it out, so that's minus 1, and this value outside of the bracket as our y. Okay, so handing it over to you now. Please pause the video and attempt these 4 questions here, and we will go over them together once you're done. Okay, so let's go through the first question. Just make some space here. So we are asked to express this equation in this format, and this is the type of question format that we would see in the exam. They won't specifically say to complete the square, but when we see this format, we know that that is what we need to use. So starting off equation in the correct format of ax squared plus bx plus c. So now we can complete the square. Starting off with an open square bracket, x plus half b, which is 3, and we're going to minus b squared, which is 9, and then add 5 at the end. Simplified, that leaves us with x plus 3 squared minus 4, where m equals 3 and n equals minus 4. Now for b, we need to solve this equation. So using our answer from part A, we are simply going to make this equal 0 and then rearrange and solve for x. And the square root of 4 is 2. So our two values for x will be minus 3 plus 2, which is minus 1, and minus 3 minus 2, which is minus 5. Moving on to question 2. Okay, just create a bit of space there. Okay, now for this question, they are just simply asking to find the turning point of this graph, meaning that we just need to complete the square and then find that one set of coordinates. So starting off, we can see it is in the correct format, so we can complete the square straight away. Open square bracket, x minus half b, which is 6, and we're going to minus b squared, so minus 36, and then plus 23 on the end, which gives us a final answer of x minus 6 squared minus 13. So our turning point of this graph will be 6 minus 13. Question 3, we can see that this is an equation where a does not equal 1. So we're going to take out 2 as a common factor, just so we can have x squared on its own. Now we can complete the square for this equation inside the bracket. Cross multiply, giving us a final answer of 2x plus 2 squared minus 4, and therefore solving this, we will need this equation to equal 0. So now let's rearrange and solve. And our final answer is x equals minus 2 plus or minus the square root of 2. For our last question, we need to find the turning point of this equation here. And again, just like the previous question, a does not equal 1 here. So let's take out 3 so we can get x squared on its own. Now we're going to complete the square for this equation inside the bracket. And if we write this as a fraction, we'll get minus 49 over 3. It's not a nice round number, but this is what we're working with. So let's multiply out. That gives us, as our final answer, 3 brackets x plus 4 squared minus 49. And therefore our turning point of this graph will be minus 4, 49.